In this video, I want to look at substitution method of solving a system of equations. So if you think about what the word substitution means, it means we're replacing or substituting in one value for another. So in the first equation, I have y equals 3x plus 3. In the second equation, I have 2x plus y equals 8. So the easier thing to substitute in here is take the 3x plus 3 and substitute it in place of this y over here. Since we have y equals this value, 3x plus 3, I'm going to take it and substitute that in place of this y in this equation. That way, this equation will be in terms of all x's. I only have one variable, which will make it easier to solve. So I have 2x plus, now instead of the y, I'm going to put in this value right here in the box, 3x plus 3, because that's what y is equal to. So 3x plus 3. And I know that this is equal to 8. Okay, now all I have to do is combine like terms. 2x plus 3x is 5x. And I've got a plus 3 equals 8. We know how to get x by itself. Since this is a plus 3, I'm going to minus 3 from both sides of the equal sign. We know whatever we do on one side, we have to do on the other. So I have 5x equals 5. Now I want to separate the 5 and the x. So to separate it, I'm going to divide, because this is saying 5 times x. So I'm going to do 5 divided by 5, because that's 1. That gives me 1 times x, which is x. And over here, 5 divided by 5 is 1. Now that I know what x equals, I can substitute again. I'm going to take this value of x and plug it in this equation in place of the x. So I have y equals 3, and instead of x, I'm going to substitute in the value of 1 plus 3. Well, we know that 3 times 1 is 3. 3 plus 3 is 6. So I have y is equal to 6. So when x equals 1, y equals 6. This is the solution to my system of equations. And we can double check. We can plug it back in. 3 times 1 is 3 plus 3 more gives me 6. If I check it on this equation over here, 2 times 1 is 2. 2 plus, in place of y, I'm putting the 6. So 2 plus 6 is in fact 8. So it works for both equations. So my solution is 1, 6. So it has exactly one solution, which makes it consistent and independent. Okay, let's look at this system. 2x plus 4y equals 8, and x is equal to 3y minus 1. We're going to use substitution again. In order to use substitution, we have to have a variable by itself set equal to something. So in this problem, x is equal to the value of 3y minus 1. So I want to take out the x in this equation and substitute it with this value, 3y minus 1. So we've got 2. Once again, we're going to replace the x with 3y minus 1. Then keep everything else just the same. Bring down the plus 4y equals 8. So I still have the same equation as I started off with, except instead of my x, I now have 3y minus 1, because we know that x is equal to 3y minus 1. At this point, I'm going to have to use the distributive property and distribute this 2 to both things in the parentheses. 2 times 3y is 6y. 2 times the negative 1 is negative 2. Bring down my positive 4y. Bring down my equals 8. Now I'm going to combine my like terms. A 6y plus 4y. They're on the same side of the equal sign, so I'm just going to go ahead and add them together. 6y plus 4y is 10y. Then I still have my minus 2 equals 8. To get y by itself, I've got to get rid of this minus 2. To get it to be 0, I add 2 to both sides. So I have 10y equals 10. Once again, to separate the 10 and the y, the 10 is being multiplied by y, so the inverse operation would be to divide both sides by 10. 10 divided by 10 is 1. 1 times y is y. 10 divided by 10, once again, is 1. So we can plug this y back in. This value of y that's equal to 1 up here in this equation. So 3 times 1 is 3. 3 take away 1, we know is 2. So when x equals 2, y equals 1. So my solution is 2, 1. We can double check. 2 times 2 plus 4 times 1 will hopefully equal 8. 2 times 2 is 4. 4 times 1 is 4. 4 plus 4 is 8. Okay, here we have 2 equals, I'm using this equation over here, 2 equals 3. In place of y, we have a 1 minus 1. 3 times 1 is 3. 3 take away 1 is, in fact, 2. So this equation works. So this is, once again, a consistent and independent system of equations because there is exactly one solution. Okay, let's look at this system. I have x plus y equals 4 and y equals a negative x plus 4. Since y is by itself, I'm going to substitute the y in this equation with what y is equal to. So I'm going to take that and I'm going to plug it in place of this x, or I'm sorry, in place of this y. So I'm going to bring my x plus down, but instead of writing y, I'm going to put negative x plus 4 equals 4. Okay, so now I can combine like terms. X plus a negative x. That is 0. So that's gone. They cancel each other out. An x and a negative x, this is all gone. So I have a positive 4 equals 4. Well, we know that's true. 4 is always equal to 4. So anytime that I end up with something like this where one side is equal to the other, that means that I had the same system of I had the same equations. If we look at it, we can tell pretty easily if I was to subtract x from both sides. If I was to rewrite this equation over here, subtracting x from both sides, I'd have y equals negative x plus 4, which is the exact same as this equation here. Well, we know from graphing that when you have the same equations, that one line is going to lie directly over top of the other one. So that means there's infinitely many solutions. But if I didn't know that, let's just say that I came to this conclusion, 4 equals 4. This is true all the time. So that means that there are infinitely many solutions to this set of equations. So when there's infinitely many solutions, that means that they are consistent and dependent. Consistent and dependent. Okay, let's look at one last problem. We're still wanting to solve by substitution. I have y is equal to 3x plus 4 and negative 9x plus 3y equals 30. Why don't you pause the video and take a second and see if you can begin this problem properly. After you've paused and tried it, then you can hit start again and see if you begin working the problem out correctly. So what I want to do is take this value that y is equal to and substitute it in place of this y over here. So I'm going to have negative 9x plus 3. In place of my y, we're substituting the value 3x plus 4, thus being the reason it's called substitution. And this is equal to 30. Okay, I want to distribute my 3. So I have negative 9x plus 3 times 3x is going to be 9x. 3 times 4 is a positive 12. And this is equal to 30. Combine my like terms. Negative 9x plus 9x. Well, that's just 0. So that's gone. And I'm just left with 12 equals 30. 12 never equals 30, obviously. So there is no solution to this system of equations. And if we were to think back to what we were doing in the past when we were looking at graphing it, let's say that I was going to get y by itself. Now I would move the 9x to the other side, divide everything by 3, so I would have y equals, be a positive 9x over here. When I divide it by 3, that's going to be 3x. Okay, then I'm going to have 30 divided by 3, which is 10. Now look at this. This and this have the same slope, but they have different y-intercepts. Therefore, I know if I was to graph them, they would be parallel. We know that parallel lines never intersect. So graphically, we know that they would be inconsistent. There would be no solution. And by solving them using substitution, we know that 12 never, ever can equal 30. Therefore, once again, there is no solution. So it is an inconsistent system of equations.